Hello everyone, I'm happy to share our work Contrastive Feature Masking Open Vocabulary Vision Transformer. This is a joint work with Anelia and Wei Chung. As we all know, object detection has been expanding its number of vocabularies from 20 classes of Pascal to 1200 in ELPIS. But there still are many more objects in the real world that are not labeled and are novel categories. And it's not feasible to manually scale up the annotations. In response to this, the open vocabulary detection was proposed by Zyran et al. In 2020 and followed by many others. Most recent open vocabulary detectors are usually built on the vision language models like CLIP because the CLIP models are good at zero-shot classification and also suitable for the region classification. This work specifically focuses on using Vision Transformer from CLIP to build a strong open vocabulary detector. While the VLMs like CLIP usually have stronger semantics like object names and attributes, the vision-only models like MAE show stronger localization ability in detection and segmentation. So in this work, our motivation is to learn a VLM that is effective in both localization and semantics, so that it improves the downstream open vocabulary detection. This shows the CLIP pre-training with a text encoder and a vid encoder. On top of the contrastive learning pathway, we propose to have this reconstruction pathway where we jointly train with contrastive and reconstruction losses. Similarly to MAE, we randomly mask out the image patches and keep only 12.5% of the tokens. They go through the same weight-shared vid encoder, followed by the MAE decoder that predicts the whole tokens. After the pre-training is done, we take the vid backbone to initialize our detector. Our detector follows the mask RCNN design with new detection layers like FPN, RPN, box, and mask head on top of the pre-trained vid backbone. During this OVD training, we have access with the base category objects, and the similarity between those base class name embeddings and the ROI aligned embeddings are detection scores. At inference, it is tested with some novel category names, and now the detection score is computed with the union of the base and novel class names. Back to our pre-training, here we had several options where we should use as the reconstruction target. One is the raw pixel values as in the original MAE, two is the features right after the petrifying layer, and three is the very last feature map. To give you the answer first, we choose 3 because neither of the raw pixels or early features was helpful in the OVD results. And reconstructing the last features, which are also being jointly trained with contrastive supervision, was the best and gave us a large gain of 3.3 AP rare. In addition to the contrastive feature masking, we propose to use positional embedding dropout during pre-training. Here we drop the whole positional embeddings by a 50% of chance. The motivation is that the model can overfit to low-res and object-centric images in pre-training, while it has the depth with high-res detection images. The PED teaches the model not to rely heavily on the positional embeddings and thus can process the high-res images better. This is the comparison with existing OVD methods. Here, CFM-vid outperforms all ConvNet and vid-based methods by a large margin. We also evaluate CFM-vid on the zero-shot image level retrieval. Both contrastive feature masking and positional embedding dropout improve the image retrieval performance. We also visualize the feature reconstruction results from our pre-training. We compute the similarity map between the reconstructed image features and a queried text embedding. And we observe that the learned feature reconstructions make sense given the queried image text pairs. In conclusion, CFM-vid is a new image text pre-training method for open vocabulary detection via contrastive feature masking and positional embedding dropout, and it shows state-of-the-art results on OVD benchmarks.